Chanda Prescod-Weinstein studies some of the most complex questions in science. Perhaps that's part of what helps her stare down tough issues here on Earth, too, such as those she's encountered as a young woman of color, breaking barriers in the STEM fields. She is assistant professor of physics and astronomy and a core faculty member in women's studies at the University of New Hampshire. And she joins us now. Welcome.
Thank you.
Chanda, it's really nice to meet you in real life. I've been following you on Twitter for a while, so it's nice to have you here in the studio.
Thank you for having me.
What drew you to the science, to the work that you do?
So when I was about 10 years old, my mom took me to see a documentary about Stephen Hawking called A Brief History of Time. So it was made by Earl Morris, named after his book. Mm-hmm. And about halfway through the movie, they were talking about how Einstein hadn't figured out what happens at the center of black holes with singularities. And I was like, wait, you can get paid to do that? And that was it. I walked out of the movie begging my mom for a copy of the book, and I just knew that that was what I wanted to do.
That's what you wanted to do. You actually wrote a letter to him, to Stephen Hawking.
I did. Yeah. So maybe a year later, I found his email address and sent an email and said, how do you become a theoretical physicist? And one of his graduate students responded and explained to me that you have to go to a good college and apply for a PhD and get a PhD, and then afterwards you become a professor. And so that's what I started to plan to do.
I think when you're a child, you just see the world being so big and everything is so incredible and you have a lot of questions. When you look back, do you remember what drew you to it? What piqued your interest, your curiosity at 11 years old to do the work that you're doing right now?
I think part of it, my parents were both activists, and so I spent my entire childhood sort of being confronted with things that weren't going right in the world and things that needed to be better about the world. And I think part of what was attractive to me about doing cosmology and particle physics was here was a thing that was sort of beyond these human concerns. And I think that was part of what was attractive to me about it. It was something that was bigger than all of us, but interested all of us, which is where do we come from? Mm-hmm. Why are we here? Like these really big esoteric questions.
Speaking of the big issues that are happening here on Earth, you are a person who is active in the National Society of Black Physicists, the Society for the Advancement of Chicanos/Hispanics and Native Americans in the Sciences, the Committee for Sexual Orientation and Gender Minorities in Astronomy, and you've also been involved with the Jewish Voice for Peace Academic Advisory Council. How do you identify?
I'm a queer Black woman who I would say I believe in pan people of color organizing and working together, and I'm an anti-racist organizer. And I think that that's what drives my work in all of those groups and organizations, that I think it's very important to focus on ending racism and working for underrepresented minorities, which in the United States is traditionally people of African descent, people who are Hispanic identified, and people who are Native American. And so I'm just very focused on how we can move towards equity and equality. And
you're also, I think, the 64th Black woman in...
So the numbers change. Uh-huh. But if we're just looking at African American women who have earned PhDs from departments of physics, I was something like number 51, number 52. And to give that context, there are about 2,000 PhDs in physics awarded every year in the United States. So even though I earned mine in Canada, and so we would have to expand the numbers a little bit, the numbers of African American women earning PhDs in physics is far too low compared to our percentage in the population.
What do you think needs to be done to make that higher, that number higher?
So I actually got a tweet from a Black woman who was an undergraduate at Waterloo when I was a PhD student there, and she said that it was very heartening to see me on campus because she had never seen a more senior Black woman. But she never reached out to me, and eventually she found that it was a very stressful environment, and without any support, she ended up switching degrees to psychology. And that's a story that I hear over and over again from Black women. A lack of mentoring, a lack of representation, a lack of support really translates into people feeling unwelcome in the field, and like people like them aren't supposed to be there. And eventually it's just emotionally grueling for a lot of people, and so they walk away.
And what do you think has allowed you to stay?
I'm really stubborn. I mean, you could ask my mom about it. It's not her favorite quality most of the time.
But it's helpful in this world.
It's helpful in this world, and I think I inherited it from her as well. Sorry, Mom. But I think you have to be unusually stubborn and unfairly stubborn. I don't think that it's not something that I would say to someone, this is a quality you have to have. I think it's a quality that is currently necessary, but I think in future, that also means that we only get a certain type of person who's acting as a scientist, who's the person who can overcome these barriers. But what about all of the people who have different types of personalities? If you're not a noisy person, that doesn't mean you're not a good scientist.
I just want to read something that you have on your website under the heading Who I Am. And you write, science is a collective human endeavor. My goal is to chip away at what we think we know and what we don't know in order to expand what we actually know. I believe the universe is always more amazing than we think it is. Is there something that struck you as more amazing about the universe recently?
I guess this isn't recent, but the one that I always like to share with people is that the pop culture black hole story that we hear is that you cross the event horizon and you fall into a black hole and then you can't get out. But I actually think that what happens is way more fantastical than that. So in fact, the properties of space and time change once you cross the event horizon. So space starts to act like time. And so as we all experience, time only goes forward. So inside a black hole, space only goes forward, which means if you try and turn around and walk away, you're still walking forwards.
That is so fascinating.
Right, that's so much better than you fell in and you can't get out, right? I love that.
Well, you study dark matter. Many people have heard that term, but I don't know if many people know what it means, myself included. Could you give us a layman's explanation?
Yeah, so I think the first thing I would say about dark matter is that I actually think dark matter is not a very good title for it. And it's definitely from a different era. It was first coined in the 1930s. So I think that at a different time, it would have gotten a different name.
What would you call it if you could?
So I think I would call it clear matter or transparent matter or invisible matter. So the main thing is that light goes through it, and that's why we can't see it. So it's very different from things that are dark, like the floor in here is dark, and I can see it just fine. Right, and that's because light's reflecting off of it still. Okay. But with dark matter, there's no reflection, light's just going right through it. And we are actually not 100% sure that dark matter exists. It's just the idea that matches our data in the best way. So there's a discrepancy between how much light we see coming from stars and how those stars are moving in galaxies, and how much mass we think a galaxy has based on the presence of those stars. So to make that mismatch work, you add dark matter into the equation and everything works out.
Why is it important to study this?
So, I think that's a really deep question, right? Yeah. That's a very, I think different people have different reasons for coming at the dark matter question. To be honest, I did not plan out a career where I was going to be working on dark matter. It's something that I fell into because of the research group I ended up in as a postdoctoral fellow at MIT. But I think that, when I say that the universe is always more fantastic than we think, we have no idea. When Einstein wrote down general relativity, we had no idea that later we would all be using it every day in the form of Google Maps because GPS requires general relativistic corrections in order to work. Right. So we actually just don't know what's around the corner and why it will be practical or what's next. But the other thing is that every human culture has come up with a cosmology and a story of where we come from. I think we're a storytelling species, and this is a storytelling process.
This is part of the story.
Yeah, this is our story.
Oh, another thing that you study are axioms. What are those?
So axioms are a hypothesized particle. Again, we don't know if it's real or if it's not. It was actually the byproduct of a mechanism that will help solve a problem in the standard model of particle physics. So you may have heard in the press that now that the Higgs was found at the Large Hadron Collider, the standard model of particle physics is complete. But it actually does have a few little problems wandering around that require some patches.
Like what?
So there's something called the strong CP problem. And with this problem, there's a prediction from the theory, so just the equations that we're writing down. These work perfectly for every other aspect of the standard model of particle physics, except they predict that the neutron will have something called an electric dipole moment. So we've been looking for decades for this electric dipole moment, and it's not there. So how do we get rid of this term in the equation? So one way of solving the problem is with this axion mechanism. A few years after people realized that you could solve the problem with this mechanism, someone else said, but wait a minute, you can solve the dark matter problem with the axion too. So what I love about the axiom is you can really kill two birds with one stone.
It must be like your job. I know you teach as well. It must be one of those things like you don't know what you're going to find out every day. It must be so exciting to do the work that you do.
Yeah, I think that one of the challenges that people run into when they're interested in science and then they really dig in and start doing science is that science is about what we don't know. It's not about what we do know. So you spend, 4 years in undergraduate reading from textbooks that say, here are the things that we know. And you can kind of get the impression that that's what science is about. It's about knowing things. But in fact, it's about being confused and not knowing. And part of being a successful scientist is being comfortable with not knowing what's going on. Science is really about what we don't know. So I think that it can be confusing, and the confusion can be stressful, because I think that in North American culture, we don't emphasize being confused as a quality, as a positive quality, right? But that's really, I think as a theoretical physicist, my job is to make things up and then see if I can find a way to match it with reality.
Yeah. Well, back in January, New Scientist magazine published an article about the so-called crisis in theoretical physics. Neil Chirok, the former director of the Perimeter Institute in Waterloo, had this to say. We are entering a crisis of the most fruitful kind, where the very foundations are in jeopardy, and that's just thrilling. I'm busy trying to persuade my colleagues here to disregard the last 30 years. We have to retrace our steps and figure out where we went wrong. First off, do you agree that there's a crisis in theoretical physics?
I think that this whole conversation, and in fact, that article was such a great example of how science is not really an objective phenomenon, but is in fact a social phenomenon. It's a thing ultimately that people are doing, right? So Neil, who's a very well-respected cosmologist, he was the senior member of my research group when I was there as a PhD student. He's a theoretical physicist. And so from his point of view, I think what he was saying is that there haven't been new, exciting theories that match some of the experimental problems that we've run into. But I think if you asked an experimentalist the same question, they would give a very different answer. So if we disregard the last 30 years, there goes the top quark, which was discovered, I think, in 1994. There goes the Higgs, which was discovered in 2012. It's been an enormously productive time for experimental particle physics. Experimental cosmology, observational cosmology. In 1998, we discovered that the universe, that the space-time is accelerating in its expansion and not just expanding. It's been enormously productive. And so I think it's really, from the point of view of theorists, we haven't necessarily done a good job at coming up with explanations for all of the things that the experimentalists and observers are seeing.
Do you think that's why he said to disregard the last 30 years, or is there another explanation?
I suppose, but I don't know if I would agree that we should disregard the last 30 years. I think that we keep plugging along, and our job is to try things out and see if they work, and if they don't work, move on to the next thing. And at the same time, we also never know when a new idea is going to completely, radically change the way that we see the world. That's certainly what happened with special relativity in 1905 and with general relativity in 1915. But I don't think you can plan for that. I don't think that you can just say, okay, now it's time for a revolution. Revolutions in science, I think, happen when they happen, and we arrive at them partly because of the work that people have been doing before we get there.
You spent some time at the Perimeter Institute. What was the most important thing you learned there?
So I guess, again, I would say science is a social phenomenon. When I was there, there was only one woman member of the faculty, and in fact, at one point she said to me, look around the room. Everybody in here thinks that they're objective, but they're just people, and they have biases too. And I think that that was actually a really important note for me, not just as a student who, had less power than a lot of the people in the room, because most of them were faculty, but also as a scientist, to always be aware of the fact that I am not an objective machine. I'm still a person. I'm still going to have my preferences. Why do I work on axioms and not some other dark matter candidate? There isn't some great logical reason for that.
But just saying that, because I think there's a lot of skepticism around science right now. Someone hearing you will say, aha, she proved my point. There is bias in science. Do you think that, how do you tell people that science is important? And just by saying that you have a bias doesn't mean that you're not going to present the facts.
So I think, again, there's a really important distinction here between theoretical physicists and experimental physicists. So if we were to take an example like global climate change, the experimental data, the observational data, is extremely clear there that we are experiencing man-made global climate change. That's not just a theory, that's something that's been tested. I do think that, for example, where you might see bias is it turns out that ExxonMobil knew that global climate change was a likely phenomenon. They were projecting this very early. I think the dates I've heard from the 1970s, 1980s, they made an active decision not to share that information with the rest of humanity. And in my view, put humanity at risk in making that decision. So I think that that's where bias comes in, is what information do you decide to share, what experiments do you decide to do, and which ones do you not do. And I think the decision not to talk about climate change early on was a very dangerous one and is a great example of how social bias can interfere with science and shape science. But I don't think that means the conclusions are wrong, but I do think that we make choices about what science we do and when we place a value on it.
And do you think there's place for that conversation to happen?
Yeah, I think there is difficulty in having that conversation, partly because I think scientists can be very tense. If we talk about how there is bias in science, then maybe people will stop believing that global climate change is real and will not feel a sense of urgency about taking action about it. And I think that we just have to grin and bear it, that we have to, the only way out is through. We have to have those difficult conversations, even if they are difficult. And as scientists, we should be prepared for that because science is hard. This is no different from the other problems that we tackle, except maybe lives depend on it. And that gives it a certain sense of urgency that the dark matter problem doesn't have.
A few years ago, you took the step to ask the professional societies that you're involved with to put out a statement supporting Black Lives Matter. Why did you decide to take that step?
I think for every person of African descent, particularly those who are darker than I am, but myself included, I would say, walking out your front door in a country where we know there is bias from not just police, but vigilantes on the streets is an act of bravery, just walking out your door. So to get to your lab, you have to walk out your front door. You have to be willing to engage the outside world and engage society. And honestly, if we look at examples, for example, the little girl Ayanna Stanley Jones, who was killed by the police while sleeping on her couch, even behind your front door isn't necessarily safe. So what I was looking for my professional societies to say, they keep telling us that diversity and inclusion matter, but Black scientists aren't just Black scientists when they're inside their classrooms or inside their laboratories. They're also Black scientists when they're at home, when they're walking down the street. And so diversity and inclusion, to the extent that those are even useful concepts to talk about, have to include having a conversation about recognizing that the lives of those people matter, even when they're not in explicitly scientific settings.
How was your request received?
So there were a group of white scientists, and particularly in the American Physical Society, who I think really heard it and wrote a letter and gathered signatures to get the American Physical Society to put out a statement about Black Lives Matter. And I think that was really heartening. Actually, one of the authors of the letter was Professor Elena Long, who's now one of my colleagues at the University of New Hampshire. And she was certainly a draw for me in making the decision to go to University of New Hampshire because I knew I had that kind of support. And I think as a barrier breaker herself, as a trans woman in experimental nuclear physics, she understood the importance of talking about violence against the communities that we are a part of and confronting that as a feature of people's everyday lives. At the same time, the lack of a statement, I think, eventually, we didn't ultimately really get a statement that explicitly said Black Lives Matter. And part of what I heard was that people who have police in their families would be upset about that. And I really don't see Black Lives Matter and the existence of police necessarily being, at least on the surface, conflicting statements. And I wonder about, my mentee who called me a few years ago and said, I was working late in the lab and I stepped out to take a phone call and a white woman walked up to me and said that if I didn't show her ID, she was going to call the police on me. What do I say to that student? Is your professional society here for you or are they not?
What did you say to the student then?
I said a lot of things that I probably shouldn't say on television. When students come to me with stories like that, they're very emotionally heartrending for me. I want to protect them. There are so many things that I can't protect the students from. When the students come, when their classmates, their white classmates come to them and say, you're only here because they needed a visible minority presence, and to try and undercut their confidence that they are accomplished people who deserve the things that they have received in the scientific community. It's very difficult to not be able to shield them from that. And I think that that drives a lot of my activism, is that I can't stop any individual incident, but maybe I can move things so that those incidents are less frequent and eventually stop.
You've also written about the sexual misconduct allegations against probably the best-known scientist, black scientist in the U.S. or anywhere, Neil deGrasse Tyson. And you wrote this about him. I was a graduate student in astronomy and feeling a bit lost in a small, very white town on a campus where not only was I the only black graduate student in my department, but I was one of only about 10 across the entire university. I emailed Tyson looking for advice. While I have very little recollection of what happened on the subsequent phone call, I do remember I felt so encouraged that Neil deGrasse Tyson had taken time out of his day to call me, and I remember distinctly that he said what I most needed to hear, that I could do it. Tyson was, yet again, an encouraging role model. But all of the men who have harassed or assaulted me have said similarly encouraging things. So the fact that I've had multiple positive interactions with Tyson over the years doesn't make it harder to believe that he is guilty of serious misconduct. We should say that he has denied the allegations. Why did you want to write this article?
It's funny, over the years, I've had a very complicated relationship with how people respond to the existence of Neil Tyson and when they disagree with Neil Tyson. And I definitely noticed a pattern that people were a little more emotional when they found that they were in disagreement with him. When he said something about a movie or about science on Twitter that people disagreed with, people would create hashtags and sound very upset. And so going into responding to this story, I was aware that because he was African American, because he was a black man, that there were going to be people who were going to say, don't talk about it because you're bringing down the race and you have a responsibility to protect black men, regardless of what they may or may not have done and what's alleged that they have done. And that there were also going to be people who were going to say, yeah, I totally believe that about him. And it was clearly going to be partly because he wasn't white, that it was easier to believe that about him. So I wanted to try and put some nuance into the conversation and say, look, this is a man, he's had positive impact on me as a fellow black person. And at the same time, that doesn't mean that we can ignore these allegations. And I'm very concerned.
Well, you've also mentioned your own experiences of assaults, and you wrote about what he was alleged to have done. Is physics a safe place for black women?
I mean, I think the question is anywhere a safe place for black women? The stories that I hear from black women in all kinds of professional/working environments indicate to me that misogynoir, the experience of misogyny paired with anti-black racism, is everywhere. So I wouldn't say that physics is particularly bad. It's not particularly great either. So that's not to say positive things about physics. That's more that these phenomena of sexual violence and rape culture, it's a social problem. And physics is a community of people, which means that we bring the social problems from larger society into our community as well. I do think that the number of black women in physics shows that it is a particularly harsh environment, even compared to, say, biology. Or, particle physics is very different from biophysics. There are a lot more black women in biophysics than there are in more traditional physics disciplines. So it's clear there are differences, but I would say I've heard horror stories from lawyers. I know that women who are working as house cleaners and domestic workers also face their own challenges with sexual violence. So I don't think physics is special.
You write a lot on top of the work that you do, but now you're actually writing a book, and it's called The Disordered Cosmos. What's it like to write a book that will live on beyond your life, and looking back at that 11-year-old falling in love with science?
So no pressure. I mean,
But what does it mean to you?
I'm very aware of the fact that it may, if it does okay, that they might keep printing it for a while. If it doesn't do okay, then they stop printing it, and maybe I don't need to worry so much, right? I think it's very challenging, particularly with this book, that I'm not just going to be writing about the science that I do, but I'm also going to be writing about how race and gender shape science and have shaped the kind of science that I do and shape Black women's experiences in the sciences. And for that reason, I've definitely experienced a lot of challenge, and I'm actually still working through this as I write. When I was a teenager, when I was 17 and leaving for university, I wasn't dreaming of becoming an expert on discrimination in physics. I was dreaming of solving problems in particle physics. And so there's a part of me that wants to write a book for that girl and to say, here's a book written to you, with you in mind, Black girl dreaming. And at the same time, I don't think that I can write a book that talks about race and gender without talking about problems. And so there's a real tension of wanting to write a book that can be put in young people's hands, and at the same time not wanting to scare them or make them think that the world isn't worth engaging with and being a part of. And that's a real point of tension, and thank God the book's not coming out for a while, so there's some time to
Well, I hope you can
think it
come back
through.
when it comes out and we can talk to you about it.
Yeah.
Chanda, it's been so great speaking with you. I've learned so much.
Yeah, thank you for having me.
Thank you for being here.
The Agenda in the Summer with Nam Kiwanuka is brought to you by the Chartered Professional Accountants of Ontario. CPA Ontario is a regulator, an educator, a thought leader, and an advocate. We protect the public. We advance our profession. We guide our CPAs. We are CPA Ontario. And by viewers like you. Thank you.